Welcome to another edition of Math for No Reason. In this edition, we are going to prove this inequality, which states that if we have two numbers x1, x2, with x1 less than x2 and they are both between 0 and pi by 2, then tan of x2 divided by tan of x1 is greater than x2 divided by x1. Now, first we note that tan x2 by tan x1 greater than x2 by x1 is same as tan x divided by x2 is greater than tan x1 by x1. So if we look at the function fx as tan x by x, then we can write this as fx2 is greater than fx1. Now, if it happens that whenever x1 is less than x2, fx1 is less than fx2, we say that the function is increasing on this interval 0 to pi by 2. So we have to show that fx is increasing on 0 to pi by 2. Now, one of the most convenient ways of showing that a function is increasing is to show that its derivative is greater than or equal to 0. In fact, here, since we are trying to show that fx is strictly increasing, so therefore we will try to show that f prime x is strictly greater than 0 on the interval 0 to pi by 2. So we compute the derivative applying the quotient rule. Now f prime x is x square x minus tan x divided by x square. X square is always greater than 0 in this interval 0 to pi by 2. So whether f prime x is greater than 0 or not would depend on the numerator. So we will try to show that the numerator x square x minus tan x is greater than 0 on this interval 0 to pi by 2. So now we consider another function gx, and gx is x square x minus tan x. Since we have to show that this is greater than 0, we also note that g0 is 0. Now we compute g prime x. The derivative of g prime x is, first we apply the product rule here. So x into derivative of sec square x, which is 2 sec x into sec x tan x. The derivative of sec x is sec x tan x, and simplifying we get 2 sec square x tan x. And the second term is x square into the derivative of x. So we get sec square x, derivative of x being 1, minus the derivative of tan x, which is sec square x. So the sec square x and sec square x cancels. So we are left with 2x sec square x tan x. On the interval 0 to pi by 2, we see that this derivative is greater than 0. So gx is greater than z0, and therefore we can say that x sec square x minus tan x is greater than. And since x sec square x minus tan x is greater than 0 for all x in this interval, therefore we can conclude that f prime x is greater than 0 for all x in this interval. So f is increasing on this interval. So we can conclude that whenever x1 is less than x2, fx1 is less than fx2. This is a good point to stop. Thank you.